Let's take a look at the kinematics question here. Since there are a lot of words, I have helped you to summarize it. So as a summary, we are given particle P, we have a displacement formula there, and for particle Q, we have acceleration. So part A of the question, find the value of T for which velocity of P and Q are equal. So this one here, we are given displacement and acceleration. We are going to equate velocity. So it's a good question for us to showcase our knowledge of kinematics. So let's do particle P first. We are given displacement as t cubed over 3 minus 3t squared over 2 plus 5t. So to find velocity of particle P, we're going to do a differentiation. So let's differentiate this. I'm going to write the s dt first. Now, let's do a differentiation. 3 multiplied by 1 over 3, that's 1. So I'm just going to write t. Reduce power by 1, that's a t squared. Minus 2 times the front is 2 times negative half. So I get negative 1. So now here, top I still have 3. So I have 3t. Differentiating 5t, answer is going to be a 5. So this one is my velocity for particle P. Now let's take a look at particle Q, where we are given acceleration equals to 2t minus 6. So to get velocity of particle Q, we are doing an integration. Let me write this down. Let's do integration step now. We're going to raise power, divide by power. So now I can see 2 and 2. I can just cancel it out. It's going to be 2 divided 2 is equal to 1. So I erase this part here. So integrating 6 is 6t. Now remember, for integration, we need to add constant c at the back. So what happened here is that, let's read the question again. We have this part here where they say t is a time in second after passing z. So this one meaning when I start the time at 0, the particle will be at z position. And you notice there's another line here. When q passes z with a velocity of 11, so what happened here is that we know when it passes z, the time is 0. So what I can do here is that we're going to substitute t equals to 0 and velocity equals to 11 at this step. So what you can see is that I will get 11 equals to 0 squared minus 6 times 0 plus c. So I get c value as 11. Therefore, I know velocity of q now is equals to t squared minus 6t plus 11 here. So now that I have velocity for P and Q, let's equate it. So we'll solve for the time now. So I have t squared minus 3t plus 5 equals to t squared minus 6t plus 11. So t squared and t squared cancel. Let's move t to the left. So I have 6t minus 3t. That's a 3t. Moving constant to the right, 11 minus 5. That's a 6. So therefore, divide by 3, time is equals to 2. That's part A of this question. Let's erase and take a look at part B. Part B of this question, explain why particle Q will always move in the same direction after passing Z. Now, moving the same direction can mean moving to the right always or moving to the left always. So if moving to the right, it will always be positive, and if to the left, it will always be negative. Now, let's take a look at this velocity here. We have the formula, which is a quadratic. Let's complete the square. Now let's take a look at this one here. Negative 6 divided by 2 is negative 3. Squaring this could be a 9. So my answer after completing square, I can change the expression to t minus 3 squared. 11 minus 9 is plus 2. Now I'm going to show you two ways to explain. First, let's think about the time. It's always more than or equals to 0. Let's start by explaining this square. Here, t minus 3 squared, the lowest is 0. So I will get more than or equals to 0. What happened to the next step is that when I add a 2, I shifted the graph up. So no more equal sign. You're going to place more than 0. So from here, you can see that velocity is always positive. And if you can say that velocity is always positive, you can prove that you always move in the same direction. So in this case, you are moving to the positive direction. Now, if you're taking a look at this graph over here, velocity time graph, and if you remember, The question stated they start 11. If you place 0, 0, you will start 11. So that's a starting velocity. And the minimum point of the graph is going to be 3, 2. So you put a point here. So this is how your graph is going to be. You can also see that velocity is always positive based on the sketch of a velocity time graph here. So that's all for part B. Let me erase, then we will look at part C of this question. Let's take a look at last part of this question. Find the average velocity of particle Q in the first 5 seconds. So we're going to have average velocity. We're going to work out the displacement first from 0 to 5. Let's write down the velocity just now. So to get displacement for velocity, I need it from 0 to 5. We're going to do integration of this one here. T squared minus 60 plus 11. And this is expression in t, so we integrate with respect to t. Let's write a dt here. Now let's do integration. So we have to raise the power, divide by power. Same goes to this. 60 squared divided by 2. Last one, integration of 11, going to be 11. Following this expression here, so it's going to be 11t. So let's shift this 0.5 to the back. We have done an integration process. Put a 0.5 here. Let's insert 5 and 0 in at this step. So insert 5. And if you can see, if you insert 0, it's going to be 0, 0, 0. Let me just put minus 0 then, okay? So next step, let's work it out. So I have 65 over 3. Last step here, average velocity for the first 5 seconds is going to be displacement from 0 to 5, which is 65 over 3, divided by the duration of time, which is 5 in this case. So let's divide by 5. So the answer here will be 4 and 1 over 3 meter per second. That's all for this kinematic question here.